In physics, work refers to the measure of energy transfer that occurs when an object is moved over a distance by an external force. Remember that the external force must be at least applied in the direction of the displacement. In short, it is the force that causes the objects to move to result in its displacement. If the work is done in constant force or constant in both magnitude and direction, it is defined as the product of the magnitude of the displacement multiplied by the component of the force parallel to the displacement. In an equation form, we can write it as W is equal to Fd, where F is the component of the constant force parallel to the displacement d. In general, we state the equation for work as W is equal to Fd cosine theta, where F is the component of the constant force parallel to the displacement d, and theta is the angle between the directions of the force and the displacement. We can deduce from this equation that the work done by a force F is just the dot product between the magnitude of the force and the displacement of the object. From this concept, what do you think is a work? Is it a scalar or a vector? Correct, it is a scalar quantity. Even if the force and displacement are both vector quantities, this is because it has no directions. It is just a magnitude and it can be positive or negative. To illustrate work, we have here a person pulling bags on a horizontal surface. The applied force is expressed in F cosine theta. The work done by the applied force F is W is equal to Fd cosine theta, where d is the displacement and theta is the angle between the force and the displacement. In calculating work, the SI unit that we use is the joule, where we use capital letter J as symbol. In our formula, work is equal to force multiplied to displacement. The SI unit of force is Newton, while the SI unit of displacement is meter. We can say from this that 1 joule is equivalent to 1 Newton meter. There are some points that you need to remember for you to evaluate or determine if the work is positive, negative, or zero. Remember, if the force is parallel to the direction of the displacement, then work is positive. If force is opposite to the direction of the displacement, then work is negative. If force is perpendicular to the direction of the displacement, then work is equal to zero. I hope this is clear. At this point, we will have some practice exercises. Let us look at this problem. Jenny had her groceries done. Inside the store, her cart was full of things that she bought. She needs to push her cart into the cashier area with a distance of 4.5 meters, where she applied 50 newtons on her cart to make it through the cashier. Determine the work done by the force of Jenny acting on the cart. In this problem, we are asked to calculate the work done by the force acting on the system. The displacement and the force are both given. We can easily substitute this in our equation. W is equal to Fd as follows: 50 newtons times 4.5 meters. The work done in this situation is 225 Newton meter or 225 joules. Let us have another example. A force equal to 15 Newton acting on a box of 1.5 meters along a horizontal surface. The force acts at a 40-degree angle as shown in the figure below. Determine the work done by force F. In this situation, we are asked to determine the work done by the force acting on the system. Again, I will post this video and try to answer this problem. Let us see if we got the same answer. Using the given displacement, which is equal to 1.5 meters, force equals to 15 newtons and the angle, which is 40 degrees. We will substitute these in our equation. W is equal to Fd cosine theta. It will be 15 newtons times 1.5 meters times cosine 40, which when we follow the equation, we will have 17.24 joules. This is the work done by the force on the box. In the next video, we will try to solve more difficult examples both in scalar dot product and the concept of work. But that is all for now. I'm Gilmer De Castro, and see you in the next video.